Hi everyone, we're opening up lesson or video number 27, reviewing the vertex form, and we're just going to do a very quick example. So the question here is asking us to write 2x squared minus 2x minus 4 in the vertex form. Recall that a bracket x minus h all squared plus k is the vertex form. Then we are to write down the coordinates of the vertex and the equation of the line of symmetry. Alright, so given that, let's quickly take a look at what we've got. We've got 2x squared minus 2x minus 4. Since our value of the a does not equal 1 in this case, then we're going to proceed to take out the 2 from the x squared and x, so that we're left with x squared minus x and then minus 4. Okay, and we've got y equals, basically. Now, we're now going to say, we're going to take the x squared minus x, and we're going to take half of x, which is x over 2, or 1/2 x, and square it. So we're going to do plus 1/2 squared, so it's plus 1/4 squared. Plus 1/4. So it'll be plus 1/4 minus 1/4, and then it'll be minus 4. So I took the half of x, which is x over 2, okay, or the half of x is just 1/2, and I'm going to square it, so it goes to 1/4. So now I have 2 bracket x minus 1/2 all squared. That is my completed the form. I have completed the square form of that, and the first 3 terms. And now because the 2 has to be multiplied by the negative 1/4, I end up getting on the outside of the bracket negative 2/4, or negative 1/2. Okay, minus 4. And so we have 2 bracket x minus 1/2 all squared minus 1/2 minus 8 over 2, which is equal to 2 bracket x minus 1/2 all squared minus 9 over 2. Alright, so that takes care of the part A. We have figured out, we have completed the square here, and we have placed it in the vertex form. And now what we're going to do is we are going to find the coordinates of the vertex. Remember that the coordinates of the vertex are actually hk. And so that means that we have got 1/2 and negative 9 over 2 is our vertex. And if we want to find our equation for the axis of symmetry, remember that x is equal to the h value of your vertex, so it becomes x equals 1/2. Okay, so that takes care of one form of a quadratic. It is the vertex form. What we're going to be looking at today is we're going to be looking at another form called the intercept form. So what does that involve? Basically, when we're looking at the intercepts, we're looking at the axis intercepts. So we're looking either at the x-intercepts and the y-intercepts. So let's assume that we wanted to find the y-intercept of a function. Okay, so we've got y equals ax squared plus bx plus c. If I now replace, when we want to find the y-intercept, we let x equal 0. If I replace that, the x with 0, I end up getting that y is equal to c. That means that in the general formula, ax squared plus bx plus c, our value of the c is always going to be the y-intercept. So, for example, given y equals x squared plus 3x plus 3, if we let x equal 0, then y equals 0 squared plus 3 times 0 plus 3. And we know that our y-intercept is 3, or 0, 3. Same thing in the next problem. Now be careful, in the next problem, we have to always put them in order from greatest degree to smallest degree. So we always go from biggest to smallest powers. And our constant is always going to be last. So that I would rewrite 8 plus 2x minus 2x squared as in negative 2x squared plus 2x plus 8. And in doing that, I figure out very quickly that my value of the c, or the y-intercept, is going to be found at 0, 8. Okay, so it's not going to be found at 2 or negative 2. okay, but it'll be the constant. Okay, now if we want to find the x-intercept, though, so we found the y-intercept, we let x equal 0. If we want to find the x-intercepts, we let y equal 0. So all we need to do is factorize to find the x-intercepts, because we've already done this. When we have solved for x, we have always solved for finding the x-intercepts or the roots or the zeros. So all we need to do is to factorize, basically. So if I give you the example, find the x-intercepts of the following functions, y equals x squared plus 5x plus 6, well, all I really needed to do there was set y equal to 0, and then I just needed to factorize it. So that is, what two numbers multiplied give me 6 and added give me 5. Now, the numbers are 3 and 2, so it's x plus 3 and x plus 2. But when we then simplify and we use the null factor law, we end up saying that x plus 3 is equal to 0 or x plus 2 is equal to 0. So x is either equal to negative 3 or x equals negative 2. Therefore, our x-intercepts are going to be either negative 3, 0, they're going to be negative 3, 0 here, and negative 2, 0 here on our graph. Okay. So that tells us, that solves our x-intercepts. Now, let's find the x-intercepts of the next example. Okay, so the x-intercepts of the next example, keep in mind that you're not always going to be using sum and product. You might have to use splitting the middle term, or you could have to use the quadratic. There could be different ways of solving for the x-intercepts. All right, as long as we know that we're setting it equal to 0. So what I do is I say 0 is equal to 4x squared minus 24x plus 36. Now before I do anything, I say, well, I do have a 4. My value of the a here is not equal to 1. Therefore, first thing I do is I check to see if I can remove a common factor. And it works out that I can remove a common factor here. And that common factor is 4. And when I do that, I end up getting that I've got 4 times, and here I've got a perfect square, or what two numbers multiplied give me 9 and added give me negative 6. And they happen to be x minus 3 and x minus 3. So that means that I have got a double root here. And if I've got a double root, that means that it's the same x-intercept. So I've got an x-intercept that is found exactly here at 3, 0. It looks something like that, and it's touching the x-axis. So this is my way of finding the x-intercepts. So I know that 0 is equal to x minus 3 times x minus 3. I divided both sides by 4, so I got rid of the 4 at this point. And so I know that x minus 3 equals 0 and x equals 3. Therefore, I know that the x-intercept, and it's a double root, the x-intercept is 3 and 0. Okay. Now, we looked at completing the square when we want to go to the vertex form, and now we've discovered that when we want to get to the intercept form, we need to just factorize. And our general formula for the intercept form is y equals, it's right here, I'm circling it right now, or putting a box around it, it is y equals a bracket x minus p times x minus q, where p and q turn out to be the x-intercepts, and our value of a is actually going to be still the same as our value of a that's found in the vertex form. It's still the vertical stretch. Okay, so let's do a couple of examples. All right, so a is still the vertical stretch, and p and q are the intercepts, the x-intercepts, and it doesn't matter which order they're placed in. So if we were given a quadratic function that was y equals x minus 2 times x plus 3, that means that the x-intercepts are actually found at 2, 0 and negative 3, 0. So the question is, can I figure out what the vertex is of this parabola? Well, if we recall, the vertex, or the line of symmetry, that's the line that divides our graph exactly in half in the middle. So if I took the midpoint between the x-intercepts, that would allow us to find the x value of our vertex, or otherwise known as the equation for the axis of symmetry. Okay, so what I can do is I can actually sketch my graph, and there's a couple of ways I can do that. So let me just erase it, and we'll do this very quickly. Okay, I'll show you very quickly how this would work. Okay, so what we would have is, I'm just going to put the graph over here. So what we would have is the two pieces of information that we know. We certainly know what our x-intercepts are from x minus 2 and x plus 3. That means that our graph goes to 2, 0, and we know that the other x-intercept is at negative 3, 0. Okay, now in order to find, so we have the x-intercepts, but we know that the graph, if we take a look at this, if we look at on the left, y, or we look above, x minus 2 times x plus 3, we know automatically here that the value of a is equal to 1, which means that our graph is going to be facing upward. It's not equal to negative. There's no negative in the front, so it's facing upward. So we're going to have a minimum point for our vertex. We can find our vertex, or our x value of the vertex, very quickly by doing what I said before, being that if I know that if I know that I have to find the middle point between here, I find the average between negative 3 and 2, then what I'm going to do is I'm going to say negative 3 plus 2 and divide that by 2. That gives me my x value, and that ends up giving me negative 1/2, or negative 0.5. So I know that negative 0.5 is my x value, or my axis of symmetry. It's negative 0.5. But in order to figure out, in order to be able to sketch the graph, I need to also have the y value. So what I do is, because I know that the x value going in is negative 0.5, I substitute x equals negative 0.5 into y equals x plus x minus 2 times x plus 3. And we end up getting negative 0.5 minus 2 times negative 0.5 plus 3. Okay. Let me rewrite that. Negative 0.5 minus 2 times negative 0.5 plus 3. And what that ends up giving us is 2.5 2.5 and another 2.5, which gives us a negative 5. Negative 5.5, I believe. Okay. So that ends up giving us, over here, we're going to end up with negative 6.25. Okay, so negative 2.5 times 2.5 should give us negative 6.25. All right, so our point, therefore, then for the vertex is going to be, the x value will be negative 0.5, and our y value will be negative 6.25. So that negative 1/2 and 1, 2, 3, 4, 5, 6.25 will be over here, and so that negative 1, negative 2, negative 3, negative 4, negative 5, negative 6, 0.25. So it's down here. So our graph will be here with a vertex of negative 1/2 and negative 6.25. So this enables us or allows us to sketch the graph. All right. So we're able to do that. Let's do another example. Okay. Let's do another example now. Okay, so on our next example, it says that we need to sketch the graph of the following, considering the value of A. Then we have to look at the y-intercept, and then we have to look at the x-intercepts. All right, so we've got y equals negative 3 bracket x minus 4 times x minus 1. Now, if we write that, if we look at this as y being equal to A bracket x minus p times x minus q, you'll see that this is in the intercept form. And if it's in the intercept form, that means that we automatically know what the x-intercepts are, and we can figure out what our y-intercept is. But we can automatically also say what our vertical stretch is. And we know that our value of A, or the vertical stretch, is equal to negative 3. Now, if we want to get the y-intercept, we let x equal 0. So we say y is equal to negative 3 times 0 minus 4 times 0 minus 1. And that gives us negative 3 times negative 4 times negative 1, which ends up giving us a negative times a positive, which gives us a negative, so it's negative 12. Therefore, I know that 0 and negative 12 is my y-intercept. So I've got the y-intercept there for graphing. Now, to get the x-intercepts, well, we know that automatically that p and q are equal to the x-intercepts, so that we could just say that the x-intercepts are found at x minus 4 equaling 0 and x minus 1 equaling 0, so that x either has to equal 4 or x has to equal 1. Therefore, 4, 0 and 1, 0 are our x-intercepts. Okay, now if we want to sketch the graph, okay, we want to get our vertex. And the only way we can get our vertex at this point is by graphing, looking at our x-intercepts. So let's see what our x-intercepts, not just finding the x-intercepts, but looking at the middle point between the x-intercepts. So let's take a look at the x-intercepts, and we can find the vertex. So to get the vertex, I do the average of the two x-intercepts, and I say 4 plus 1 divided by 2 is equal to 5 over 2, which is equal to 2.5. Now, to get the y value that corresponds to that, what I do is I substitute to find the y value. I substitute x equals 2.5 into the given equation, and I end up getting that it's negative 3 times 2.5 minus 4 times 2.5 minus 1, and I end up getting 6.75. All right, so I can now graph the 3 points that I have. I actually have 4 points, but I don't have enough room up here to graph the y-intercept at 0, 12. So that I'm going to graph 4 and 0, 1, 2, 3, 4, 0, my first x-intercept. I'm going to graph my next x-intercept, which is 1 and 0. And then I'm going to graph my next one, which is the vertex that we found, which was 2.5 and 6.75. So 1, 2, 3, 4, 1, 2, okay, let's try that again. 2.5. So it's 1, 2, and a half is here. 1, 2, 3, 4, 5, 6, and 0.75 is just approximately there. We're looking at an approximation here, okay? So that we've got our graph looking more or less like this. And as we go down in the graph, we should be hitting negative 12 somewhere down here for my y-intercept. Okay, and there's our graph of y equals negative 3 bracket x minus 4 times x minus 1. All right, that's it. That's all I have to say. Your homework will be in section 17C.1 and 17C.2, and I'll see you next time.